Okay, this is the continuation of our discussion. So solve natin itong problem na ito na given, ano? Papakita ko yung solution yan. Actually, this was your assignment. So this is number 2. Sulat natin muna yung given. Taburahin muna natin. Okay, the given is the following. Sabi dito, 2 currents I1 equals I2. 2 current is equals to I1, which is equal to 12. 12 sine 2 pi 60t and I2 9 cosine 2 pi 60t flow in a wire. So determine the equation of the resultant current I3 and angle between I1 and I3. Determine RMS of I3. So given muna tayo. We have I1 equal to 12 sine 2 pi 60t. Then I2 is equal to 9 cosine 2 pi 60t. So required letter A. Resultant I3 at saka theta at saka yung RMS na I3. So solution. Taas natin ng konti. Okay. For the solution, we have I3 is equal to square root of 12 squared plus 9 squared, which is equal to 15 amperes. Tangent theta is equal to 9 over 12. Itong dalawa yan. Which is equal to 3/4. Then, kunin mo yung arctangent on both sides. Theta na lang dito, which is equal to arctangent of 3/4. Therefore, the phase angle will be 36.87 degrees. Let's use a red ink. And we have I3 is equal to 15 sine 2 pi 60t plus 36.87 degrees, which is equal to 15 sine 377t plus 36.87 degrees. So this is for I3. Diyan natin ng box. Letter B. Kunin natin yung RMS value ng I3. So I3 is equals to I maximum over square root of 2, which is equal to 15 over square root of 2. So therefore I3 is equal to 10.607 ampere. Okay. Let's go now to the next topic. Wait lang. Okay. We go now to AC circuit. Circuit with resistance only. So kapag meron kang circuit na resistance lang, halimbawa ito pure resistance sa AC yan, ang current mo, which is this, no? Ito. Kapag purely resistive at yung voltage mo ay in phase. O ito na naman tayo sa word na in phase, ano? Pag sinabi mong in phase, sabay sila, no? Wala silang phase angle kasi sabay nga sila. Yung current ay dumadaan from 0 to 180 going to 360. Yung voltage ay ganun din. Mas mataas nga lang yung magnitude ng voltage. In phase yan. So, pag purely resistive ang circuit, in phase din ang phasor diagram nila. Ito yung phasor diagram or vector diagram I mean. So in phase, ito yung current, ito yung E equals to IR, no? Ito yan, bali ito. Ito yung pinaka-vector diagram nila. So the voltage at any instant is equal to the current at that instant time a constant. So that voltage wave must be in phase with the current wave. So makikita nyo sa diagram natin ng phasor diagram, mas malaki talaga yung voltage kaysa sa current. No? So the voltage at any instant is equal to the current at that instant, sabi no. So let it be required to find or determine the impressed EMF having an instantaneous wave E and an RMS value E. Wherein E is equals to the instantaneous current times the resistance. And then E is equals to yung equation ng current. I maximum sine omega t multiplied by the resistance. So mapapansin mo, pag binultiply mo ito dito, ito yan, pinasok mo dyan, IMR sine omega t. But E maximum is the maximum voltage of the wave, no? So therefore, E is equals to E maximum sine omega t. And E maximum is the current maximum times the resistance. So E maximum is equals to square root of 2E. Yan yung mga formulang dapat yung tandaan, no? Where E is the RMS value of the voltage. I maximum is equals to square root of 2I. Where E maximum is equals to I maximum times the resistance. So E maximum is square root of 2E. I maximum is square root of 2I. Cancel mo ito. Cancel mo yung dalawang square root. Matitira E is equals to IR. Or E has a formula of the current times the resistance. Simple Ohm's law. So note, with resistance only, the alternating current circuit follows the same law as the direct current circuit in regard to the relation existing among the voltage, current, resistance, and power. So pag circuit with inductance lang, paano naman? Inductance always opposes any change in the current. So ang inductance ay parang resistance din, no? Sinasalungat niya yung kahit na anong pagbabago na nangyayari sa isang kuryente, no? So inductance, it is the opposition to the building up of magnetic flux. When the current starts to increase in a circuit with inductance, the EMF of self-inductance E opposes the increase. And when the current starts to decrease, it tends to prevent this decrease. So with steady current, direct current, the inductance has no effect, no? Pag steady lang yung direct current, walang epekto itong inductance. Kung halimbawa DC. Nagiging effective lang ang inductance pag alternating or pulsating current. So, ito yung sine wave niya, no? Pag inductive, meron siyang phase difference na 90 degrees. Ito yung phasor diagram niya. Kung ipapakita mo siya sa vector diagram, ito yung current ng circuit. Pag inductive, ito yung voltage, no? So, ibig sabihin ng ganito, the current lags the voltage by 90 degrees. In other words, nauuna yung voltage sa current ng 90 degrees. No? Nauuna yung voltage sa current ng 90 degrees. Tatandaan yan sa inductance. So, kapag ang alternating current ay in-apply mo dahil sa isang purely inductive coil, nagkakaroon siya ng tinatawag natin na back EMF. Ito ay napoproduce dahilan sa tinatawag nating self-inductance ng coil. Yung back EMF ng bawat step nun ay sumasalungat sa pagtaas o pagbaba ng kuryente dun sa coil. At wala siyang ohmic voltage drop, no? Yung applied voltage, kinakailangan niyang balagpasan yung self-induced EMF lang, no? So ito yung mga formula na dapat yung tandaan. Yung instantaneous current is E maximum over I maximum sine omega t, no? Sine omega t minus 90 degrees. Teka, bakit ganito? I maximum to actually. Yung power, E maximum times I maximum times sine 2 omega t over 2. And yung E is E maximum sine omega t. So XL is the angular frequency times the inductance. And XL, yung angular frequency, ang formula niya ay 2 phi F. No? Angular frequency is 2 phi F times the inductance. So XL is known to be the inductive reactance. No? Ang unit niyan ay ohms. Excuse me. So pag circuit naman na purong capacitance, kapag ang circuit, ang direct current voltage ay inimpress mo sa isang plate ng ideal o perfect capacitor, nagkakaroon siya ng initial na pagdaloy ng kuryente na nagiging dahilan para mag-charge yung capacitor mula dun sa voltage na in-apply mo sa kanya, yung DC, no? Pero pagkatapos nito, wala nang kuryente na dadaloy kapag yung impressed voltage ay nanatili lang o na constant, no? So, kapag ang capacitor plates niya, ito yung tinatawag na plates. Kapag short circuit mo yan, ang nangyayari, yung capacitor voltage with zero current, no? Ay dumadaloy yan from positive plate of the capacitor. So, ganito yung phasor diagram ng isang purely capacitive circuit. Nauuna ng 90 degrees ang current sa voltage. Kaya kung pakikita mo yung vector diagram niyan, ito ang itsura, no? Nauuna yung current ng 90 degrees sa voltage. So yung E sub C, yung voltage na capacitive voltage, ang formula niya is I times X sub C. Okay? 90 degrees yan, phasor diagram. So ang kuryente raw ay binibigay sa rate ng flow ng charge ng ganito, no? I is equals to dQ over di. Where Q stands for the charge on plates. Ito ay change in charge over change in current. So charge on a plate at that instant. So yung capacitance, the charge divided by the instantaneous voltage, and yung charge is equals to the capacitance times the instantaneous voltage. Substitute number 2 in 1. So I is dCE over dt. Tapos lalabas mo yung C, dE over dt yan, no? So, but E is E maximum sine omega t. Therefore, I is C change in maximum sine or derivative ng E maximum sine omega t. So, kunin mo yung derivative niyan. Ito ay we stand for a constant. Lalabas dito. Tapos d sine omega t over dt magiging cosine omega t multiplied by the omega. So, I is C omega E maximum cosine omega t. So from function of negative angle, yung cosine omega t is equals to negative sine, parenthesis theta 90 minus 90 degrees, which is also equal to sine theta plus 90 degrees. Therefore, I is the capacitance times the angular frequency times the maximum voltage cosine omega t sine omega t plus 90 degrees. where I maximum is the capacitance multiplied by the angular frequency times A maximum, where I maximum, maximum current, E maximum, maximum voltage, C capacitance. Therefore, I is equals to I maximum sine omega t plus 90. No, shows that the current leads the impressed voltage wave by 90 degrees. So use the other hand if the current I no on the other hand, if the current I is I maximum sine omega t be given. So derive siya, no, for the sake of explaining lang naman ito. Sinubstitute yan hanggang sa mag-up sa formulang nito, no? E ay maximum over 1 over x sub c. So sine omega t, and E is I maximum times the capacitive reactance sine omega t, where E maximum is equal to I maximum divided by the angular frequency of the capacitance, or I maximum over x sub c. No? Kasi ito may formula na 2 pi f times c. Ito angular frequency times the capacitance. Ang xc kasi ay 2 pi f c. Yung 2 pi f doon ay itong angular frequency na to. So, pag kinuha mo ang sun wave ng power, halimbawa, ito yung para sa current. Ito yung para sa voltage. Pag kinuha mo yung pag kinuha mo yung power, voltage times current is equal to power. Pag minultiply mo yung dalawang yan, ito ang mapoproduce. Puro positive lang, no? Yan yung power. Bakit na doble? Dali lang. Dito ang ginamit ay integration, doon ang ginamit ay pareho rin ang naging resulta. Doble lang yung page. Tanggalin ko na lang ito. So X is given by the formula 1 over angular frequency times the capacitance, or 1 over 2 pi Fc. So ito yung mga formula, no? Sa capacitive reactance, I is I maximum sine omega t plus 90, E is equals to E maximum sine omega t plus times t, and X sub C is 1 over the angular frequency times the capacitance, which is equal to 1 over 2 pi Fc. So, sagutan natin na itong example 1 ay 60 Hz, voltage of 115 volts, 100 ohm resistance. A, write the time equation for the voltage and the resulting current. Let the 0 point of the voltage wave be at time is equals to 0. So, ibig sabihin, nagdadaan siya sa 0, no? From 0 to 90 to 180 to 270 to 360. Ibig sabihin, liha mo daw na yung 0 point ng voltage wave na maging time ay 0. Yung starting point niya ay 0. So, pakita mo rin daw yung voltage tsaka current on the vector diagram. Pakita mo rin voltage and current on the phasor diagram. So, given, no? Class natin. The frequency is equal to 60 Hertz. The RMS voltage is equal to 115 volts. Yung resistance is equal to 100 ohms. Required letter A, time equation for the voltage and the current. Letter B, ano pa yung kailangan? Letter B, show the voltage, show E and I on a vector diagram. Letter C, phasor diagram. Balik natin sa ayos. So, solve for A, no? Letter A, so we have E is equals to E maximum sine omega t. So I is equals to I maximum sine omega t. So I is equals to, yung I maximum has a formula of E maximum over R. Sine omega t. So E maximum is equal to square root of 2 E. Square root of 2 multiplied by 115 volts, which is equal to 162.5 63 456 volts. Saglit lang. And then, nakuha natin yung maximum, no? Pero, hindi naman yan ang hinahanap. Actually, this is circuit with pure resistance, no? And then, solve natin yung current, no? Current is equal to 162.63 456 over 100 ohms sine 2 pi ft. So I is equals to 1.62635 sine 376.99112. And the voltage, which is equal to 162. This is the time equation. 0.63456 sine 376.99112 T. Number to 1, 2, 3, 4, 5, 6, 7, 8. So dapat nasa gitna. 1, 2, 3, 4 sa baba. 1, 2, 3, 4. Okay. So yung vector niya ay ito, no? Ito yung para sa current. Tapos ito yung para sa voltage. In phase kasi purely resistive siya. Ito yung current mo. So, lagyan natin ng box itong dalawang to. So, yung kasi sa letter A. So, that's the equation. And then, letter A. Tapos, ang nahanap ko, show the voltage and current on the time diagram. Show the voltage and current. That will be show the voltage and current on a time diagram. Sumunod phasor diagram. Sulat. Show the voltage and current on a vector diagram. Ito yung letter B. Tapos, vector diagram. Tapos, show the voltage and current on a phasor diagram. So, phasor diagram. Bakit muna natin ito ng konti. Para lumawag dito sa baba. So, ito yun, no? And then, sumunod din yung, ano, no? Phasor diagram. Wait lang, ha? So, phasor diagram niya, pakita ko lang. Yung letter C, no? Sa given niya. Ayun. Letter C. So, circuit with pure resistance yun. So, example naman ito para sa purely inductive, no? So, yung 60 Hertz voltage daw, na ang voltahe ay 230 volts, um, ito yung effective value niya. So, pag sinabi natin effective value, RMS din yun. In-apply daw siya sa isang inductor na nagtataglay ng 0.265 Henry. So, sulat mo raw yung time equation for the voltage at saka yung resultant current. Gawin mo daw na yung zero axis ng voltage wave ay magsimula sa zero at ipakita mo raw yung voltage at current sa isang phasor diagram. Hanapin mo daw yung maximum energy na na-store o naipon sa loob ng inductor or inductance. So, given. Frequency niya ay equal sa 60 Hz. Ang RMS value niya, RMS voltage niya ay given as 230 volts. Yung inductance niya ay 0.265 Henry. So, ang required letter A, yung time equation, no? So, the time equation for the voltage and resulting current. Letter B, yung phasor diagram daw. Letter C, the maximum energy stored, no? Which is ano bang Greek letter yan? So, solution. Letter A. Para sa letter A, ang solution natin is, dito ko pala nasusugatan ng solution. So, letter A, E is equals to E maximum sine omega t. E is equals to yung RMS value ng voltage E maximum over the square root of 2. So, derive natin yung E maximum from the equation above. E maximum is equals to square root of 2E. Then, substitute natin, no? Square root of 2 multiplied by the voltage E to 30 volts. Therefore, E maximum is equal to 325.629 volts. No? So, nakuha na natin yung E maximum. So, pag nakuha mo na yung E maximum, kunin naman natin yung kasi ang hinahanap ay equation, no? For the voltage and resulting current. So, kaya hindi natin ito lalagyan ng box kasi hindi naman yan talagang hinahanap. So, yung angular frequency, may formula na 2 pi f, which is equal to 2 pi multiplied by 60 hertz, which is equal to 377 radian. Okay? Ito yung angular frequency niya. No? Ano pa kulang? Pwede na nating i-substitute sa equation ng instantaneous voltage. So, let's call this 1. Lagyan natin ng highlight. Okay. Then, let's start now with letter A. For letter A, we have the instantaneous voltage. Taas natin konti ito. We have the instantaneous voltage equal to 325. Yung E-maximum kasi, 325. 325. Yan yung E-maximum, 0.629. Sine A by T. So, yan yung nakuha natin sa, ito ngayon lang lalagyan ko lang box, no? Red box. Wait lang. Wait lang. So, nalagyan ko na ng box yun, no? Ay, tinitignan lang ako. So, ang susunod na hinahanap sa kanya ay yung time equation for the voltage and resulting current. Nakuha na natin yung current naman ang kailangan natin, no? Sabi lang natin. Baba ko lang ito. Okay. Yung current naman, no, solve na natin kasi pati yung equation sa voltage, yung current naman. So, paano yung sa current? I maximum is equal to E maximum over X sub L, no? But X sub L, tawagin natin itong equation. But X sub L has a formula of 2 pi FL. So therefore, you have 2 pi multiplied by the frequency, which is 60, and the inductive reactance, which is 0.265. So therefore, the inductive reactance will be given as 99.9026 ohms. So tingnan nyo, hindi ko muna binax, no, kasi hindi naman siya ang hinihingi. Then let us solve for I maximum, no? I maximum is equal to yung nakuha mong value sa E maximum. We will place I maximum is equal to E maximum. E maximum is equal to 325, no? 325.629 volts. Divided by X sub L, no? Divided by yung X sub L niya, no? Which is 99.9026 ohms. So therefore, I maximum is equal to 3.2595 amperes ang unit niya. Lalagay mo kasi yan sa maximum. Pero huwag na muna lagyan na ito. Ito na pala yung I maximum. So, ang nakuha ay 3.2595, no? Amperes. So, pwede na natin sulat yung equation. I is equals to my maximum sine omega t minus 90 degrees. Therefore, I is equal to 3.2595 Kaya nilagay ko lang sine ngayon ng 3 pi t times 90 degrees. So, traduhan ko din yung ganito. Ayan. Okay. So, ang isa pang requirements dyan ay hinahanap yung maximum energy na na-consume nitong tignan ko. Oh. Pinapahanap ko. Ito yung phasor diagram. So, yung phasor diagram niya ay magiging ganito, no? So, letter B. Letter B, yung phasor diagram, no? So, let 3.5 unit is equal to 325.629 volts. Wait lang. So 3.5 unit is 325.629. Therefore, 1 unit, pag-assign ka ng unit pag mag-graph ka is equal to 93.0369 volts. Tapos yung isa naman, yung 2.5 unit is equal to 3.25 amperes. Tapos 1 unit ngayon, one unit is equals to 93.936039, 93.0369 volts yan. So let 2.5 unit so 1 unit is 93.0369 volt. Let 2.5 unit, no, is equal to 2.5 unit is equal to ganun. Is equals to 3.25 amperes. 1 unit is equal to 1.3 amperes. Then, dagdag pa natin yung page. So therefore, Ba ako napunta? Ano ba nangyari? Wala. Okay, sagot ng number 2 next is ito, no? Ano ba yun? Okay, XC, ang formula ng capacitive reactance, reciprocal ng 1 over 2 pi FC. So therefore, yun yung 1.3 ampere. No? So, secret ng class. Ituloy ko lang, no? So, na-solve natin is equation para sa current. No? Sumunod yung phasor diagram naman. So, let 3 halves unit equals 3.25.629. 1 unit is 93.0369. At yung isa naman, 3.25, yung gumagawa ako ng ratio. Ano? Okay? So, we have 325 and kunin natin to. Wait lang. Okay. Yung pinaka-phasor diagram natin. para sa ano to, no? Inductive. Tapos sumunod na pinapahanap yung energy sa loob ng inductance. No? So how is that? Letter C. The energy in the inductance, maximum energy niya, which is ang formula niyan ay 1/2 L I maximum squared. Wait lang. Yung pinaka-phasor diagram. Tapos yung pinaka-uli, kasi ko ba nilagay? Yung formula. Therefore, E sub L is equal to the maximum energy and maximum energy. Which is equal to 1/2 multiplied by 0.265 Henry multiplied by 1/2 0.265 multiplied by 3.253. The energy is equal to 1/2 multiplied by 0.265 Henry multiplied by 3.253 3.253 squared. So the energy of the inductor is equal to 1.0 1.4082. Okay. And 408. Ganito. Okay, EL is equals to input pagbawa. Sulat ko. Joule dapat. Okay, next page. Save ko na to ah. Stop muna natin yung video.